Module 9.1, Pitch. In the introduction to logarithms, I spoke about the octave keys on the piano as an example of how we perceive exponential stimuli as being linear. And I explained that we use loudness, Fons, and dBSPL to describe how we perceive changes in sound pressure. The word we use to relate how we perceive differences in frequency is pitch. Pitch is defined as the characteristic of a sound that allows us to say that it is higher or lower than another sound with relation to frequency. In certain circumstances, the pitch you hear may not be the actual frequency that is being produced, and we'll see examples of that later. Notes are specifically named pitches. Note and pitch are often used interchangeably. We use the first 7 letters of the alphabet A through G, 2 symbols, sharp and flat, plus a number to name pitches. For example, C4 is the note commonly referred to as middle C. The basic unit of pitch is the octave. As we said earlier, notes that are an octave apart have a 2-to-1 frequency ratio, that is, a doubling or a halving of frequency. Notes that are an octave apart have the same pitch name, for example, C3 and C4, and this is because we perceive notes that are an octave apart as having the same character. In a string instrument, if you half the length of a vibrating string, you produce a pitch that is an octave higher. Likewise, halving the length of a tube raises its pitch 1 octave. Double the length of a tube, or closing one end of an open tube, lowers the pitch by an octave. By the way, if you're wondering why octave means doubling when the prefix oct stands for 8, that's because in 1 octave there are 8 notes in a major scale. For example, C, D, E, F, G, A, B, C. We'll learn more about scales in Module 10. If you look at a piano, there are 13 black and white notes from any note C to the next C. This series of notes is called a chromatic scale. Let's look at the frequencies of those 12 chromatic notes. As it turns out, and as you might expect, since frequency of octaves increases exponentially, the frequency difference from note to note increases exponentially. Yet, the frequency ratio from note to note is the same, and to our ear, the difference from note to note sounds the same. So, once again, you can see that our sense of frequency change is logarithmic or ratio-based, not linear, and that's why we refer to musical notes rather than frequencies. It's more convenient, and it corresponds to what we hear. To review, pitch is the characteristic of a sound that allows us to say that it is higher or lower than another sound with relation to frequency. A note is a specifically named pitch. The terms note and pitch are often used interchangeably. The basic unit of pitch is the octave. Pitches that are an octave apart have a 2-to-1 frequency ratio and have the same note name. A chromatic scale is 12 notes within an octave that have the same frequency ratio between adjacent notes.